12,800 years ago, something fell from the sky. The Earth shuddered. Ice sheets that had stood for millennia cracked and collapsed in a matter of decades. Temperatures plummeted 10 degrees in 10 years. Sea levels surged 400 feet across the globe. Entire species vanished overnight. The greatest hunters of North America, the Clovis people, disappeared without explanation. Their sophisticated stone tools, their thriving settlements, their mastery of the continent, all erased as if they had never existed. What happened during those final moments of the last ice age wasn't gradual climate change. It wasn't the slow retreat of glaciers or the gentle warming of spring. It was catastrophe on a planetary scale, a reset button pressed on civilization itself. For decades, scientists struggled to explain the Younger Dryas period, that mysterious 1,000-year return to ice age conditions that interrupted Earth's warming trend. Traditional theories pointed to ocean currents, volcanic eruptions, or gradual shifts in solar radiation. But the evidence painted a different picture entirely, one of sudden violence. Of fire raining from the heavens, of a cosmic visitor that changed everything. The first clues emerged not from ancient texts or mythological accounts, but from the ground itself. In sediment layers spanning 4 continents, researchers began finding materials that shouldn't exist. Microscopic diamonds formed under impossible pressures. Glass melted at temperatures exceeding 2,000 degrees. Platinum scattered in concentrations that defied explanation. Magnetic spherules that could only form in the fury of cosmic impact. At Abu Huraira in Syria, archaeologists uncovered a black layer marking the boundary between worlds. Above it, the remains of early agricultural communities. Below it, the debris of something far more violent. The glass fragments embedded in that dark stratum told a story of instantaneous vaporization, of temperatures hot enough to melt stone and fuse sand into crystal. Plant matter had been flash burned into the molten material, preserving the final moments of a world transformed by fire. The scale of destruction stretched across continents, from the channeled scablands of Washington State, where floodwaters had carved canyons through solid bedrock, to the Great Lakes region, where massive ice dams had burst and released torrents of meltwater. The geological scars remained, written in stone and sediment, waiting for modern science to decode their meaning. But this wasn't just another extinction event buried in deep time. This catastrophe had witnesses, human beings who lived through the chaos and somehow found ways to remember. In the ruins of their settlements, archaeologists discovered evidence of a remarkable transformation. Communities that had thrived as mobile hunters suddenly began building monuments. Not simple shelters or burial mounds, but massive stone circles aligned with astronomical precision. At Göbekli Tepe in Turkey, hunter-gatherers who had never farmed a day in their lives somehow organized the labor to move 100-ton pillars and carve elaborate reliefs depicting cosmic events. The site's construction began almost immediately after the proposed impact date, as if those who survived felt compelled to record what they had witnessed in permanent stone. Computer analysis of the carved star patterns revealed something extraordinary. The astronomical alignments didn't match the sky of their own time, but rather the heavens as they appeared nearly 2,000 years earlier, during the exact period when the cosmic catastrophe struck. The survivors didn't just build monuments, they revolutionized human society. Within centuries of the impact, the first domesticated wheat appeared in fields near Göbekli Tepe. The agricultural revolution that would reshape human civilization emerged not gradually over millennia, but suddenly, as if born from necessity. Communities that had wandered seasonally for generations began settling in permanent villages. They developed new technologies, new social structures, new ways of organizing large groups of people. It was as if the cosmic catastrophe had shattered the old world and forced humanity to rebuild from the ground up. The trauma of survival had become the catalyst for civilization itself. The evidence continued to accumulate. In New Jersey, Maryland, and South Carolina, researchers found the same telltale signatures embedded in sediment cores. Shocked quartz grains fractured in web-like patterns unlike anything produced by terrestrial processes. Melt glass spherules that had cooled rapidly from temperatures exceeding volcanic eruptions. Platinum concentrations spiked at levels typically associated with asteroid impacts. The geographic distribution painted a picture of multiple airbursts across North America, as if a fragmented comet had exploded in the atmosphere and rained debris across half the continent. Unlike the classic impact crater scenario, these were low-altitude events that left no obvious holes in the ground but scattered their signature across thousands of square miles. Modern physics provided a framework for understanding such destruction. The Tunguska event of 1908 had demonstrated how a relatively small cosmic object could flatten 2,000 square kilometers of forest without ever reaching the surface. The proposed Younger Dryas impactor would have been thousands of times larger, fragmenting into countless pieces that detonated across the atmosphere like a cosmic shotgun blast. The timing was too precise to ignore. The Clovis culture vanished at 12,800 years ago. The North American megafauna went extinct at 12,800 years ago. The Younger Dryas cooling began at 12,800 years ago. The melt glass layers, the platinum spikes, the shocked minerals all appeared at 12,800 years ago. Either this represented the most remarkable coincidence in geological history, or these events shared a common cause. Yet for years, the scientific establishment resisted the cosmic impact hypothesis. Critics argued that the evidence could be explained by terrestrial processes. Volcanic eruptions, they claimed, could produce similar chemical signatures. Wildfires might account for the carbon spherules. Normal weathering could concentrate rare metals in sediment layers. But as more research teams examined sites around the world, the evidence became harder to dismiss. Independent laboratories confirmed the presence of nanodiamonds, materials that form only under the extreme pressures of cosmic impact. Melt glass samples showed isotopic ratios inconsistent with terrestrial volcanism. The geographic distribution of impact markers extended far beyond any known volcanic event, spanning from North America to Europe to the Middle East. The debate revealed deeper questions about how science evaluates revolutionary ideas. The cosmic impact hypothesis challenged fundamental assumptions about climate change, extinction patterns, and the development of human civilization. It suggested that catastrophe rather than gradual evolution had shaped our recent past. For a scientific community invested in uniformitarian principles, such ideas seemed dangerously close to catastrophism, a discredited 19th century notion that Earth's history was punctuated by sudden disasters. But the evidence refused to conform to comfortable theories. In Greenland ice cores, researchers found platinum spikes and other impact markers precisely dated to the Younger Dryas boundary. In lake sediments across Europe, the same chemical signatures appeared at the same time horizon. The pattern was global, synchronous, and unlike anything in the preceding geological record. The implications stretched beyond academic debates about extinction and climate. If a cosmic impact had indeed triggered the Younger Dryas cooling, it meant that human civilization had emerged from the ashes of global catastrophe. The monuments, the agriculture, the settled communities that marked the beginning of the Neolithic Revolution weren't just cultural innovations. They were survival strategies developed by people who had witnessed the end of their world and were determined to preserve something for the future. In this light, sites like Göbekli Tepe took on new meaning. The massive stone circles weren't just religious centers or astronomical observatories. They were memory palaces, repositories of knowledge encoded in stone by people who understood that wood and clay and organic materials could be destroyed in an instant, but properly aligned megaliths might endure for millennia. The carved reliefs at Göbekli Tepe depicted not just animals and abstract symbols, but cosmic events. Vultures circling overhead, serpents descending from the sky, headless human figures scattered across the landscape. Some researchers interpreted these images as metaphorical representations of the impact event itself. The vultures as scavengers cleaning up after mass death, the serpents as cometary fragments streaking through the atmosphere, the headless figures as the victims of cosmic catastrophe. If this interpretation proved correct, then humanity's oldest monumental architecture served as both memorial and warning, a stone record of the day the sky fell, preserved by survivors who wanted future generations to remember that such things were possible, that the cosmos could be cruel as well as beautiful, that civilization itself was fragile, dependent on forces beyond human control. The agricultural revolution that followed took on similar significance. Communities that had relied on hunting mammoth and mastodon suddenly found themselves in a world where large game had vanished. The old ways of life were no longer sustainable. Survival required new strategies, new forms of cooperation, new relationships with the natural world. The domestication of wheat near Göbekli Tepe might represent humanity's first conscious attempt to create abundance rather than simply harvest it. People who had witnessed the sudden disappearance of their primary food sources understood the need for reliable alternatives. They began selecting seeds, nurturing plants, transforming the landscape itself to ensure that future catastrophes wouldn't leave them helpless. Within a few centuries, these innovations spread across the Fertile Crescent and beyond. Villages grew into towns, towns into cities. Writing systems emerged to record transactions and preserve knowledge. Social hierarchies developed to coordinate increasingly complex projects. The foundations of civilization, as we know it, took root in soil still settling from cosmic bombardment. The transformation wasn't limited to the Middle East. Across the globe, human societies that had remained relatively unchanged for thousands of years suddenly began experimenting with new forms of organization. In China, the earliest evidence of rice cultivation appeared shortly after the Younger Dryas boundary. In Mesoamerica, communities began domesticating maize and beans. The pattern suggested not coincidence but necessity, as if the cosmic catastrophe had created a worldwide crisis that demanded innovation. The speed of these changes defied conventional archaeological models. Traditional theories suggested that agriculture developed gradually over millennia, with small improvements accumulating slowly through trial and error. But the evidence from multiple continents pointed to rapid, almost simultaneous breakthroughs in food production and settlement patterns. It was as if humanity had been forced to compress thousands of years of cultural evolution into a few desperate centuries. The survivors of the Younger Dryas impact faced challenges that modern humans can barely comprehend. The collapse of the North American ice sheet had unleashed floods of biblical proportions. The channeled scablands of eastern Washington bore witness to water volumes that dwarfed any river system on Earth today. Torrents carrying more water than all the world's rivers combined had carved their signature into bedrock, creating a landscape of geological violence that still puzzled observers 12,000 years later. These weren't gradual floods that communities could flee or adapt to over generations. They were walls of water hundreds of feet high, moving faster than any human could run. Everything in their path simply vanished, swept away by forces that could move boulders the size of houses and carve new valleys in solid stone. The scale of destruction made the great floods of recorded history seem like spring showers by comparison. Yet somehow, people survived. Small groups scattered across high ground, watching their world disappear beneath churning waters. When the floods finally receded, they found themselves in an alien landscape. Familiar landmarks had vanished. Rivers flowed in new channels. The very geography had been rewritten by cosmic violence. The psychological impact of such an event would have been as profound as the physical destruction. Communities that had passed down oral traditions for countless generations suddenly found those stories inadequate to explain what they had witnessed. The old myths spoke of seasonal floods, of normal disasters that fit within the natural order. But this catastrophe transcended human understanding, demanding new explanations and new forms of remembrance. The response was monumental architecture on a scale never before attempted. At Göbekli Tepe, teams of workers hauled massive limestone pillars across miles of rough terrain without wheels, without domesticated animals, without any of the technologies that later civilizations would consider essential for such projects. The logistics alone suggested a level of organization that shouldn't have existed among hunter-gatherer societies. Each pillar required hundreds of people working in coordination, quarrying the stone, shaping it with primitive tools, transporting it to the construction site, and raising it into position with nothing but ropes and human muscle. The effort represented a fundamental shift in human priorities, from immediate survival to long-term preservation of memory and meaning. The astronomical alignments built into these structures revealed sophisticated understanding of celestial mechanics. The builders tracked not just the obvious cycles of sun and moon, but the subtle precession of equinoxes that changes star positions over thousands of years. They encoded these observations in stone with mathematical precision that wouldn't be matched until the development of advanced civilizations millennia later. This knowledge hadn't emerged from peaceful contemplation of the heavens. It was born from trauma, from the desperate need to understand forces that could remake the world without warning. The survivors who built Göbekli Tepe weren't just creating monuments to their gods. They were constructing early warning systems, astronomical computers designed to detect the cosmic threats that had already destroyed their world once. The carved pillars depicted creatures both familiar and strange. Serpents, scorpions, vultures, and wild boar mingled with abstract symbols that might represent stellar constellations or atmospheric phenomena. Some reliefs showed humanoid figures without heads, their necks ending in rough stumps. Mainstream archaeology interpreted these as ritualistic or mythological imagery, but other researchers saw literal depictions of impact effects, bodies decapitated by shock waves or debris from exploding comets. The serpent imagery appeared particularly significant. In many ancient cultures, serpents represented both wisdom and destruction, the dual nature of cosmic forces that could nurture life or obliterate it. The carved serpents at Göbekli Tepe might preserve memories of comet tails streaking across the sky. Their undulating forms burned into human memory by the terror of what followed. As construction continued at the site over several centuries, the architecture evolved in telling ways. The earliest circles featured the largest pillars and most elaborate carvings, as if the builders were working from vivid, first-hand memories. Later phases showed smaller stones and simpler designs, suggesting that direct recollection of the catastrophe was fading into cultural tradition. Eventually, the entire complex was deliberately buried under tons of earth, sealed away like a time capsule. The burial of Göbekli Tepe raised profound questions about the intentions of its creators. Why would people invest such enormous effort in constructing these monuments only to hide them from future generations? Perhaps they believed the knowledge encoded in stone was too dangerous for ordinary times, meant to be preserved only for future catastrophes, when such information might prove essential for survival. Similar patterns of monumental construction emerged across the ancient world. At Nabta Playa in southern Egypt, nomadic peoples erected stone circles aligned with stellar positions from the same epoch as the proposed impact. In Malta, massive temple complexes featured astronomical alignments and sophisticated acoustic properties that suggested advanced understanding of physics and engineering. In the Americas, earthwork complexes appeared suddenly in the archaeological record, their geometric precision rivaling later civilizations. The global distribution of these monuments implied communication networks spanning continents, as if scattered survivors were sharing knowledge and techniques across vast distances. Trade routes that wouldn't be documented for thousands of years might already have existed, carrying not just goods, but information about cosmic threats and survival strategies. The development of agriculture followed similar patterns of rapid innovation and long-distance transmission. Domesticated crops appeared almost simultaneously in regions separated by thousands of miles, suggesting either remarkable coincidence or coordinated efforts to ensure food security against future catastrophes. Communities that had never needed to store grain for more than a few months suddenly began building granaries capable of feeding populations through multi-year famines. The social structures required to support these innovations represented another revolutionary change. Hunter-gatherer societies typically organized around small, egalitarian bands with fluid leadership and minimal specialization. But the construction of monumental architecture and the management of agricultural surpluses demanded permanent hierarchies, specialized craftsmen, and complex systems of labor organization. These weren't gradual adaptations to changing circumstances. They were emergency responses to existential threats, social innovations born from the recognition that traditional ways of life were no longer adequate for survival in a cosmos that could strike without warning. The trauma of the Younger Dryas impact had forced humanity to reinvent itself, to develop new forms of cooperation and knowledge preservation that would eventually become the foundations of civilization. The speed of this transformation suggested that human beings possessed capabilities that only emerged under extreme pressure. Communities that had remained culturally stable for thousands of years suddenly demonstrated remarkable creativity and adaptability when faced with unprecedented challenges. The cosmic catastrophe hadn't just destroyed the old world, it had revealed hidden potentials within human nature itself. Modern research continued to uncover evidence supporting the impact hypothesis. Advanced dating techniques confirmed that the extinction of North American megafauna occurred within decades of the proposed impact date. Genetic analysis of crop species revealed rapid diversification events that coincided with the Younger Dryas boundary. Archaeological surveys identified settlement pattern disruptions across multiple continents, all synchronized to the same narrow time window. The consistency of timing across such diverse lines of evidence made alternative explanations increasingly difficult to maintain. Critics who attributed the changes to gradual climate shifts struggled to explain why those shifts would produce identical effects in regions with vastly different environmental conditions. The global synchronicity pointed toward a common cause, something that could affect the entire planet simultaneously. That common cause was becoming clearer as researchers refined their understanding of impact mechanics and atmospheric processes. Computer models of comet fragmentation showed how a single large object could break apart in Earth's atmosphere and distribute its effects across multiple continents. The resulting air bursts would create the observed pattern of destruction without leaving obvious impact craters, explaining why traditional searches for cosmic collision sites had proven fruitless. The implications stretched far beyond academic debates about prehistoric catastrophes. If cosmic impacts could trigger rapid climate change and mass extinction events on such recent timescales, they represented ongoing threats to modern civilization. The survivors of the Younger Dryas impact had rebuilt their world from scratch, developing new technologies and social structures adapted to post-catastrophic conditions. But contemporary humanity possessed no such experience, no cultural memory of planetary-scale disasters or their aftermath. The monuments these ancient peoples left behind weren't just impressive feats of engineering. They were textbooks written in stone, preserving knowledge that oral tradition alone could never maintain across generations of trauma and displacement. Each megalith served as a data point in humanity's first systematic attempt to understand and predict cosmic behavior, born from the urgent necessity of preventing another surprise from above. The sophistication of these early warning systems became apparent as researchers decoded the mathematical relationships embedded in their construction. At Göbekli Tepe, the spacing between pillars corresponded to specific stellar distances, creating a three-dimensional map of celestial mechanics that could track the movement of potentially dangerous objects across thousands of years. The builders weren't just commemorating what they had witnessed, they were calculating when it might happen again. This represented a fundamental shift in human consciousness, from passive acceptance of natural forces to active attempts at prediction and control. Communities that had previously lived entirely in the present suddenly began thinking in terms of centuries and millennia. They developed conceptual frameworks for understanding cyclical time, recognizing that cosmic events might follow patterns observable to those with sufficient patience and precision. The knowledge systems they created drew connections between earthly phenomena and celestial events that wouldn't be formally recognized by science until modern times. They understood that impact events could trigger climate changes, that atmospheric disturbances could affect weather patterns, that cosmic debris might continue arriving in waves long after the initial catastrophe. This holistic view of planetary systems emerged not from theoretical speculation, but from direct observation of cause and effect on a global scale. Archaeological evidence suggested that these early scientists shared their findings across vast networks of communication and trade. Similar astronomical alignments appeared at sites separated by thousands of miles, indicating either remarkable parallel development or active collaboration between distant communities. Standardized measurement systems emerged simultaneously in multiple regions, as if survivors were coordinating their efforts to create compatible databases of cosmic knowledge. The agricultural innovations that accompanied this astronomical revolution showed similar levels of systematic planning and cross-cultural exchange. Domesticated varieties of wheat, barley, and other crops appeared almost simultaneously across the Fertile Crescent, each adapted to specific local conditions, but sharing genetic modifications that suggested coordinated breeding programs. These weren't random experiments by isolated farmers. They represented organized efforts to create food security networks capable of sustaining populations through extended periods of environmental instability. The speed and scale of crop development challenged conventional models of plant domestication. Traditional theories suggested that the transition from wild to cultivated varieties required thousands of years of gradual selection and adaptation. But genetic analysis revealed that major changes in seed structure, germination patterns, and nutritional content occurred within centuries of the Younger Dryas boundary. It was as if desperate communities had compressed millennia of agricultural evolution into a few critical generations. The urgency behind these efforts became clearer when researchers examined pollen records from the period. The cosmic impact hadn't just triggered immediate fires and floods, it had destabilized atmospheric chemistry, creating acid rain that persisted for decades and altered soil composition across vast regions. Traditional food sources became unreliable or disappeared entirely, forcing communities to develop alternatives that could survive in contaminated environments. The development of fermentation technologies during this period reflected similar adaptive pressures. Communities that had never needed to preserve food for extended periods suddenly began creating techniques for storing grain and other perishables through multiple seasons of scarcity. Beer brewing, bread making, and cheese production all emerged during the centuries following the impact, representing innovations born from necessity rather than leisure. These preservation methods served dual purposes, maintaining nutritional resources while creating trade goods that could support long-distance exchange networks. Communities specializing in different aspects of food production began trading surpluses, creating economic relationships that transcended traditional tribal boundaries. The cosmic catastrophe had forced isolated groups to recognize their interdependence, laying foundations for the complex trade systems that would eventually span continents. The social structures required to manage these innovations represented another revolutionary development. Traditional hunter-gatherer societies had operated with minimal hierarchy, but the coordination required for monument construction and agricultural development demanded new forms of organization. Specialized roles emerged for astronomers, engineers, farmers, and traders, creating the occupational diversity that would characterize later civilizations. Leadership patterns evolved to support long-term planning rather than immediate decision-making. Communities needed individuals capable of maintaining focus on projects that might require generations to complete, people who could balance immediate survival needs against future security concerns. The emergence of hereditary authority structures during this period might reflect attempts to ensure continuity of knowledge and purpose across multiple lifetimes. Religious and philosophical systems also transformed in response to cosmic trauma. Traditional animistic beliefs that saw divine forces in natural phenomena suddenly seemed inadequate to explain planetary-scale catastrophes. New mythological frameworks emerged that incorporated concepts of cosmic cycles, divine judgment, and cyclical destruction and renewal. These weren't just abstract theological concepts, but practical tools for understanding and predicting environmental changes. The flood narratives that appeared in cultures worldwide during this period preserve specific details about water behavior, survival strategies, and post-disaster reconstruction techniques. Stories like those found in Mesopotamian, Hebrew, and Hindu traditions contained practical information about boat construction, food storage, and community organization disguised as religious instruction. They served as both historical record and survival manual for communities that understood catastrophes could recur. Burial practices underwent similar transformations, shifting from simple disposal of the dead to elaborate preservation rituals that reflected new concepts of time and continuity. Communities began creating permanent cemeteries, establishing physical connections between past and future generations that reinforced cultural memory. The investment of resources in monumental tombs suggested beliefs about posthumous existence that extended individual identity beyond biological death. These changes in death rituals might also reflect practical concerns about population genetics and cultural transmission. Communities that had survived near-extinction events understood the importance of maintaining genetic diversity and preserving accumulated knowledge. Elaborate funeral rites could have served as mechanisms for reinforcing social bonds and ensuring that essential information passed from older to younger generations. The artistic traditions that emerged during this period showed similar preoccupations with permanence and memory. Cave paintings, carved symbols, and decorated artifacts began incorporating motifs that would persist for thousands of years, creating visual languages that could communicate across cultural boundaries. These weren't just decorative expressions, but information storage systems designed to preserve crucial knowledge in forms that could survive social disruption. Astronomical imagery dominated these early art forms, with recurring motifs of spirals, circles, and radiating lines that might represent comets, explosions, or other cosmic phenomena. Animal depictions often showed creatures in distress or death, possibly preserving memories of extinction events. Human figures frequently appeared headless or fragmented, images that could represent impact casualties or symbolic references to social disruption. The mathematical concepts embedded in these artistic traditions revealed sophisticated understanding of geometric principles and numerical relationships. Patterns based on specific ratios and proportions appeared consistently across different media and geographic regions, suggesting either direct cultural transmission or shared underlying knowledge systems. These mathematical constants would later become fundamental to architectural and engineering traditions in classical civilizations. The metallurgical innovations that accompanied these cultural changes reflected both practical needs and symbolic purposes. Communities began working with copper, gold, and other metals, not just for tools and weapons, but for objects with ceremonial or astronomical significance. Metal artifacts from this period often showed precise craftsmanship that suggested specialized knowledge and dedicated workshops, rather than casual experimentation. The appearance of copper working coincided with evidence for increased trade networks and resource extraction activities. Communities were venturing farther from their home territories to obtain materials that weren't locally available, indicating both improved transportation technologies and expanded geographic knowledge. The risks associated with long-distance travel must have been balanced by urgent needs for specific materials or information. Obsidian trade networks that emerged during this period spanned thousands of miles, connecting communities from Anatolia to the Levant and beyond. The precision required for obsidian knapping and the standardization of blade forms across distant sites suggested both technical expertise and quality control systems that implied organized production and distribution networks. These weren't casual exchanges between neighboring groups, but coordinated economic activities that supported specialized craftsmen and long-distance traders. The development of these trade networks created opportunities for rapid transmission of innovations and ideas across vast distances. Techniques for monument construction, astronomical observation, and agricultural management could spread between communities within decades rather than centuries. The cosmic catastrophe that had initially isolated survivor groups ultimately catalyzed their reconnection through shared needs and complementary specializations. Navigation technologies advanced rapidly during this period as communities established regular contact across difficult terrain. Knowledge of stellar navigation, seasonal patterns, and geographic landmarks became essential for maintaining trade relationships and coordinating construction projects. The astronomical expertise developed for cosmic threat detection found practical applications in terrestrial travel and communication. The psychological adaptations required for these cultural transformations were perhaps as significant as the technological innovations. Communities had to develop new concepts of risk assessment, long-term planning, and collective decision-making. Traditional approaches that prioritized immediate gratification and individual autonomy became liabilities in an environment that demanded sustained cooperation and delayed rewards. Educational systems emerged to transmit complex knowledge across generations, moving beyond informal apprenticeship models to structured programs that could preserve specialized information. The development of mnemonic techniques, symbolic notation systems, and ritualized knowledge transmission reflected recognition that crucial information could be lost if not actively maintained and reinforced. These educational innovations created the first intellectual elites, individuals whose primary social function involved knowledge preservation and transmission rather than immediate resource production. The emergence of priestly classes, astronomical observers, and master craftsmen represented a fundamental shift in social organization that would characterize complex societies for thousands of years. The cosmic impact that had nearly destroyed human civilization ultimately became the catalyst for its transformation into something far more sophisticated and resilient. The survivors who witnessed the skyfall had responded not with despair, but with determination, creating systems of knowledge, cooperation, and cultural preservation that would outlast any individual community or generation. Their legacy lived on not just in the monuments they built, but in the very structure of human society itself. The transformation wasn't limited to monumental architecture and agricultural innovation. Deep within human consciousness itself, something fundamental had shifted. The survivors of the cosmic catastrophe carried psychological scars that would reshape how their descendants understood existence itself. Fear became a teacher, trauma became wisdom, and the memory of falling skies became the foundation for humanity's first systematic attempts to control fate through knowledge. Archaeological evidence from settlements across the post-impact world revealed a striking pattern of behavioral changes. Communities that had previously built temporary shelters began constructing permanent structures with thick walls and reinforced roofs, as if expecting attacks from above. Storage facilities appeared everywhere, not just for grain, but for tools, materials, and finished goods. These weren't the modest caches of nomadic peoples preparing for seasonal migrations. They were arsenals against uncertainty, repositories designed to sustain communities through extended periods when normal resource acquisition might prove impossible. The social psychology of these survivor communities manifested in new forms of leadership and decision-making structures. Traditional consensus-based governance, suitable for small bands with immediate concerns, gave way to hierarchical systems capable of maintaining focus on long-term projects spanning multiple generations. Someone had to remember the astronomical calculations. Someone had to oversee the grain storage rotation. Someone had to ensure that essential knowledge didn't die with its current keeper. These weren't gradual political evolutions driven by population growth or resource competition. They were emergency adaptations implemented by people who understood that their survival depended on institutional continuity. The cosmic impact had demonstrated that individual brilliance and traditional wisdom could vanish in an instant, but properly organized communities might preserve essential capabilities through any catastrophe. The emergence of writing systems during this period reflected similar urgencies. Oral tradition, however sophisticated, remained vulnerable to disruption. A plague, a local disaster, or even the natural death of key knowledge keepers could erase centuries of accumulated understanding. The first symbolic notation systems weren't developed for poetry or commerce, but for preserving information too crucial to risk losing. Early writing focused heavily on astronomical observations, agricultural cycles, and disaster preparedness protocols. Clay tablets from Mesopotamian sites dating to this period contain detailed records of celestial events, weather patterns, and crop yields that read more like scientific databases than literary works. These scribes weren't recording stories for entertainment. They were documenting survival strategies for communities that understood how quickly their world could change. The mathematical concepts embedded in these early records revealed cognitive sophistication that challenged traditional assumptions about prehistoric mental capabilities. Complex calculations involving orbital mechanics, seasonal variations, and resource allocation appeared alongside geometric principles that wouldn't be formally recognized by classical mathematics for thousands of years. The cosmic catastrophe had forced rapid intellectual evolution, pushing human minds to grapple with concepts that peaceful agricultural societies might never have needed to consider. Architecture from this period showed similar mathematical sophistication applied to practical concerns. Buildings weren't just constructed for shelter, but designed as integrated systems for resource management, astronomical observation, and community coordination. The famous circular structures found across Europe, the Middle East, and the Americas shared proportional relationships that suggested either direct cultural transmission or convergent solutions to common engineering challenges. These architectural innovations weren't purely functional. They incorporated symbolic elements that reinforced cultural memory and social cohesion. Decorative motifs consistently referenced cosmic themes, stellar alignments, and cyclical processes that connected daily life to larger patterns of universal order. Living within these structures meant constant exposure to reminders about humanity's place in a dynamic and potentially dangerous cosmos. The development of metallurgy during this period reflected both practical needs and symbolic purposes that extended far beyond simple tool manufacture. Bronze working required sophisticated understanding of chemical processes, temperature control, and alloy composition that implied dedicated research and experimentation programs. Communities were investing significant resources in developing technologies that offered marginal improvements over existing stone and wood implements, suggesting motivations beyond immediate utility. The symbolic significance of metals in post-impact cultures became apparent in burial practices and ceremonial objects. Gold, copper, and bronze artifacts weren't just status symbols, but embodied concepts about permanence, transformation, and cosmic connection that related directly to trauma recovery and cultural continuity. Working with fire to transform raw materials into useful objects might have served as metaphorical processing of the cosmic fire that had transformed their world. Trade networks that emerged to support metallurgical development created economic relationships that transcended traditional territorial boundaries. Communities began specializing in specific aspects of metal production, from ore extraction to smelting to finished goods manufacture, creating interdependencies that required sustained cooperation and coordination. The cosmic catastrophe that had initially isolated survivor groups ultimately catalyzed their integration into larger economic systems. These trade relationships facilitated rapid transmission of technological innovations and cultural practices across vast distances. Techniques for astronomical observation developed in one region could be adapted and refined by communities thousands of miles away within decades of their initial discovery. The shared trauma of cosmic impact had created common interests that overcame ethnic, linguistic, and geographic barriers to cooperation. Navigation technologies advanced rapidly to support these expanding trade networks. Knowledge of stellar navigation became essential not just for ocean voyages, but for overland travel across unfamiliar terrain. Communities developed sophisticated techniques for determining direction, estimating distances, and locating specific destinations using astronomical references that remained constant despite changing landscapes. The psychological dimensions of navigation took on particular significance for communities that had experienced geographic disruption. Traditional landmarks had been destroyed or altered by floods and earthquakes, making familiar territories alien and threatening. Stellar navigation offered psychological as well as practical benefits, providing fixed reference points in a cosmos that had proven itself capable of sudden violence, but retained underlying mathematical order. Educational systems emerged to transmit navigational knowledge along with astronomical observation, metallurgical techniques, and agricultural management skills. These weren't informal apprenticeships, but structured programs designed to ensure that essential capabilities survived even if their current practitioners didn't. The development of teaching methodologies reflected recognition that knowledge transmission had become a survival skill as crucial as hunting or farming. The emergence of specialized educational roles created new social categories that would persist throughout human history. Teachers, scholars, and knowledge keepers became distinct occupational groups with specific responsibilities for cultural preservation and transmission. Their social status reflected community recognition that intellectual capabilities were as essential for survival as physical strength or manual skills. Religious and philosophical systems evolved to incorporate these new understandings of cosmic order and human vulnerability. Traditional animistic beliefs that located divine forces in natural phenomena expanded to include celestial mechanics and cyclical processes that operated on timescales far beyond individual experience. Deities associated with sky, fire, and transformation gained prominence in mythological systems that previously emphasized earth-based spirits and seasonal cycles. These theological developments weren't just abstract speculation, but practical frameworks for understanding and responding to environmental challenges. Religious narratives that incorporated concepts of cosmic cycles provided conceptual tools for long-term planning and risk assessment that secular knowledge systems couldn't easily accommodate. Mythology became applied psychology, helping communities maintain focus on generational projects despite immediate hardships. Ritual practices developed to reinforce cultural memory and social cohesion around shared trauma and recovery experiences. Ceremonial reenactments of cosmic events served multiple functions, preserving historical information while providing emotional processing opportunities and strengthening community bonds. These rituals weren't just religious observances, but therapeutic interventions designed to maintain psychological resilience across generations. The artistic traditions that emerged during this period incorporated both aesthetic and informational functions that reflected new relationships between beauty and utility. Decorative motifs weren't just visually pleasing, but encoded practical information about astronomical cycles, agricultural timing, and resource management strategies. Art became a storage medium for essential knowledge, beautiful enough to preserve, but functional enough to justify the resources invested in its creation. Musical traditions evolved similarly, incorporating rhythmic and melodic patterns that facilitated memorization of complex information. Songs weren't just entertainment, but mnemonic devices for preserving astronomical observations, agricultural knowledge, and historical narratives that might otherwise be forgotten. Musical performance became a technology for information preservation that could survive cultural disruption and transmission across linguistic boundaries. The development of musical notation systems paralleled advances in other symbolic representation techniques. Communities needed methods for recording and transmitting complex rhythmic and melodic patterns that carried essential cultural information. The mathematical relationships underlying musical harmony provided additional frameworks for understanding cosmic order and natural processes that connected aesthetic experience to practical knowledge. Dance traditions incorporated similar informational functions, using choreographed movements to represent astronomical cycles, agricultural processes, and historical events. Group dances served as both educational tools and social bonding activities that reinforce community identity and cultural continuity. The physical coordination required for complex dance performances created metaphorical experiences of collective action that supported other cooperative endeavors. These artistic traditions created cultural products that could survive social disruption while maintaining their informational content. Unlike purely utilitarian technologies that might be abandoned or forgotten during crisis periods, artistic practices possessed intrinsic appeal that motivated their preservation, even when their practical functions weren't immediately apparent. Beauty became a survival strategy, ensuring that essential knowledge remained embedded in cultural practices that communities wanted to maintain. The integration of aesthetic and practical functions in post-impact cultures reflected deeper philosophical developments about the relationship between order and beauty, function and meaning. Communities that had experienced cosmic chaos developed appreciation for harmony, proportion, and mathematical relationships that connected immediate experience to universal principles. This wasn't just intellectual sophistication, but emotional healing, finding beauty in patterns that provided psychological comfort after traumatic disruption. Agricultural practices continued evolving beyond simple crop domestication toward complex ecosystem management that reflected sophisticated understanding of ecological relationships. Communities began creating artificial landscapes that optimized not just immediate food production, but long-term soil fertility, water management, and biodiversity preservation. These weren't just farming techniques, but environmental engineering projects that required multi-generational planning and coordination. The development of irrigation systems during this period demonstrated hydraulic engineering capabilities that rivaled later classical civilizations. Communities were moving massive quantities of water across difficult terrain using techniques that required precise mathematical calculations and coordinated labor management. The scale of these projects suggested both technical expertise and social organization that challenged traditional assumptions about prehistoric capabilities. Terracing technologies appeared simultaneously across multiple continents, indicating either remarkable parallel innovation or direct cultural transmission of engineering knowledge. The mathematical principles underlying effective terrace design required understanding of soil mechanics, water flow, and structural engineering that implied systematic experimentation and refinement over extended periods. These weren't intuitive discoveries, but scientific achievements that resulted from dedicated research programs. The genetic diversity of crop species developed during this period revealed systematic breeding programs that went far beyond random selection of favorable characteristics. Communities were manipulating plant genetics with precision that suggested both theoretical understanding of hereditary mechanisms and practical experience with controlled breeding techniques. The speed of crop improvement indicated coordinated efforts involving multiple communities sharing genetic material and breeding strategies. Storage technologies evolved to support these agricultural innovations, with sophisticated granary designs that could preserve seeds and harvested crops through extended periods of scarcity. These facilities incorporated understanding of moisture control, pest management, and chemical preservation that protected stored resources against various forms of degradation. The investment in storage infrastructure reflected recognition that food security required planning for worst-case scenarios rather than just typical seasonal variations. The social organization required to manage these agricultural systems created new forms of collective decision-making and resource allocation. Communities needed mechanisms for coordinating planting schedules, managing water rights, and distributing harvest surpluses that balanced individual interests against collective needs. The emergence of formal governance structures during this period reflected practical requirements for agricultural management rather than abstract political theories. Legal systems began developing to resolve disputes over land use, water access, and crop ownership that arose from intensive agricultural practices. These weren't just conflict resolution mechanisms, but frameworks for establishing property rights and contractual obligations that could support long-term investment in land improvement and infrastructure development. The codification of agricultural law created precedents for later legal traditions that would govern complex societies for thousands of years. The psychological impact of agricultural development extended beyond material security to include fundamental changes in how communities understood their relationship with natural processes. Farming required thinking in terms of annual cycles, seasonal planning, and delayed gratification that represented significant departures from hunter-gatherer mindsets focused on immediate resource acquisition. Agriculture became a form of applied optimism, betting on future stability despite recent experience of cosmic chaos. These cognitive adaptations influenced other aspects of cultural development, creating mental frameworks that supported long-term projects and institutional continuity. Communities that had learned to plant crops in spring while planning for autumn harvest could also invest in monument construction, knowledge preservation, and trade relationship development that required sustained effort over extended periods. Agricultural thinking became a template for civilizational thinking. The environmental modifications required for intensive agriculture created anthropogenic landscapes that represented humanity's first systematic attempts to redesign natural systems according to human priorities. These weren't just practical interventions, but expressions of recovered confidence in humanity's ability to shape environmental conditions rather than merely adapt to them. The cosmic catastrophe that had initially demonstrated human powerlessness ultimately catalyzed developments that enhanced human agency and environmental control. Water management systems became particularly sophisticated as communities developed techniques for capturing, storing, and distributing rainfall and river flow that maximized agricultural productivity while minimizing flood risks. These hydraulic projects required understanding of watershed dynamics, seasonal variation patterns, and soil absorption rates that connected local engineering decisions to regional environmental processes. The construction of permanent settlements around agricultural centers created new spatial relationships between human communities and natural landscapes. Villages and towns weren't just collections of shelters, but integrated systems that optimized both agricultural production and social coordination. Urban planning became a conscious practice that balanced functional requirements against aesthetic preferences and symbolic meanings. architecture evolved beyond simple shelter construction toward complex building programs that served multiple community functions simultaneously. Structures incorporated spaces for food storage, craft production, social gatherings, and religious ceremonies that reflected the integrated nature of post-impact community life. Buildings became tools for social organization as much as protection from environmental conditions. The development of craft specialization within agricultural communities created economic relationships that connected food production to other forms of value creation. Potters, weavers, metalworkers, and other artisans began producing goods that could be traded for agricultural surplus, creating market systems that distributed both material products and technical knowledge across expanding geographic networks. These economic developments required new forms of value measurement and exchange mechanisms that could facilitate trade between communities with different resource bases and production capabilities. The emergence of standardized weights, measures, and medium of exchange reflected mathematical sophistication and social coordination that supported increasingly complex economic relationships. The integration of agricultural, craft, and trade activities within single communities created social complexity that required new forms of leadership and decision-making. Traditional authority structures based on hunting prowess or shamanic knowledge became inadequate for managing communities with diverse occupational groups and conflicting economic interests. Political innovation became necessary for maintaining social cohesion while accommodating increasing internal differentiation. The emergence of formal political institutions during this period reflected both practical needs for community governance and symbolic requirements for cultural continuity. Leadership roles became associated with specific responsibilities for agricultural management, craft production oversight, and trade relationship maintenance that required specialized knowledge and sustained commitment. Political authority began incorporating technical expertise rather than just traditional legitimacy. These governmental developments created precedents for institutional structures that would characterize complex societies throughout subsequent history. The separation of different governmental functions, the establishment of formal leadership selection processes, and the codification of decision-making procedures all emerged during the centuries following the cosmic impact as communities adapted to new social and economic realities. The psychological foundations of political authority also evolved as communities developed new concepts of legitimacy based on competence rather than just tradition or charisma. Leaders needed to demonstrate capability for managing complex projects, maintaining trade relationships, and coordinating community responses to environmental challenges. Political success became associated with technical knowledge and administrative skills that could be evaluated and compared. The documentation of governmental decisions and policies created early administrative records that preserved information about community management techniques and policy outcomes. These records weren't just bureaucratic procedures, but experimental databases that allowed communities to evaluate the effectiveness of different approaches to common problems. Government became a form of applied social science that generated knowledge about human organization and collective decision-making. The expansion of trade networks during this period created international relationships that required diplomatic protocols and conflict resolution mechanisms capable of managing disputes between communities with different cultural practices and economic interests. The development of diplomatic institutions reflected recognition that sustainable trade relationships required formal frameworks for negotiation and agreement enforcement. These diplomatic innovations created precedents for international law and treaty making that would influence human political development for thousands of years. The cosmic catastrophe that had initially fragmented human populations ultimately catalyzed their reintegration into larger political and economic systems that transcended traditional tribal and territorial boundaries. The cultural exchange facilitated by expanding trade networks accelerated technological innovation and artistic development as communities shared techniques, materials, and aesthetic concepts across vast distances. Ideas that might have taken centuries to spread through gradual cultural diffusion could now be transmitted directly through commercial relationships and diplomatic contacts. The standardization of measurement systems, currency mechanisms, and quality control procedures created common frameworks that facilitated trade while preserving local cultural distinctiveness. Communities could participate in international economic networks while maintaining their unique identities and traditional practices. Globalization became compatible with cultural diversity rather than requiring cultural homogenization. These developments created the foundations for civilization as later generations would understand it, with complex social hierarchies, specialized occupational roles, formal political institutions, and integrated economic systems that connected local communities to regional and international networks. The cosmic catastrophe that had nearly destroyed human society ultimately became the catalyst for its transformation into something far more sophisticated and resilient than anything that had existed before the sky fell and changed everything forever. The monuments these survivors built weren't just impressive displays of engineering prowess, they were time capsules constructed with the desperate urgency of people who understood that knowledge could vanish as quickly as the world they had known. Every stone circle, every astronomical alignment, every carefully carved symbol represented humanity's first attempt to create permanence in a cosmos that had revealed its capacity for sudden change. At sites across the globe, researchers began finding evidence of this systematic knowledge preservation effort. The stone circles of Britain, the megalithic temples of Malta, the earthworks of North America all shared mathematical relationships and astronomical orientations that suggested coordinated planning rather than independent innovation. These weren't isolated communities stumbling towards similar solutions. They were participants in humanity's first international scientific project. The precision of these monuments defied conventional assumptions about prehistoric capabilities. At Newgrange in Ireland, a passage tomb built shortly after the proposed impact date allows sunlight to penetrate its inner chamber only during the winter solstice. The alignment is so exact that the light beam illuminates a specific carved spiral for just 17 minutes on the shortest day of the year. The builders had calculated celestial mechanics with accuracy that wouldn't be matched by professional astronomers for thousands of years. Similar precision appeared in monuments across continents. The medicine wheels of North America tracked stellar positions with mathematical accuracy that required generations of careful observation. The stone alignments of Karnak in France incorporated geometric principles that connected earthly measurements to cosmic distances. The megalithic temples of Malta featured acoustic properties that amplified specific sound frequencies, creating resonant chambers that might have served as both communication devices and consciousness-altering environments. The consistency of design principles across such vast distances suggested that survivor communities were sharing not just techniques, but underlying theoretical frameworks. They had developed common mathematical languages for describing cosmic relationships, standardized measurement systems for translating observations into permanent records, and coordinated construction methods for creating monuments that could preserve essential information across millennia. This knowledge sharing required communication networks that spanned continents, connecting communities separated by thousands of miles of difficult terrain. The establishment of these networks represented one of humanity's greatest logistical achievements, requiring navigation techniques, transportation technologies, and social protocols that could maintain contact between distant groups, despite the dangers of post-catastrophic travel. The motivation for maintaining such connections went beyond simple trade or social contact. These communities understood that their individual survival depended on collective knowledge preservation. No single group possessed all the information necessary to predict and prepare for future cosmic events. Only by pooling observations, sharing calculations, and coordinating monument construction could they create early warning systems adequate to the scale of the threat they had witnessed. The astronomical knowledge these networks preserved revealed sophisticated understanding of celestial mechanics that incorporated both observable phenomena and theoretical predictions. Communities were tracking not just obvious cycles like solar and lunar movements, but subtle variations in stellar positions, planetary orbits, and cometary appearances that required centuries of continuous observation to document accurately. The mathematical concepts underlying these astronomical calculations included advanced geometry, trigonometry, and even rudimentary calculus techniques that wouldn't be formally recognized by academic mathematics for thousands of years. The cosmic catastrophe had forced rapid intellectual development as communities grappled with problems that required mathematical tools their traditional knowledge systems couldn't provide. The integration of mathematical and astronomical knowledge created predictive capabilities that extended far beyond simple calendar keeping. Communities could forecast eclipses, predict seasonal variations, and identify potentially dangerous celestial objects years or even decades before they posed direct threats. These early warning systems represented humanity's first systematic attempt to gain advance notice of cosmic dangers. The construction techniques required to translate these calculations into permanent monuments demanded engineering capabilities that rivaled later classical civilizations. Communities were quarrying, transporting, and positioning massive stone blocks with precision that required sophisticated understanding of leverage, friction, and structural mechanics. The logistics of coordinating hundreds of workers in complex construction projects implied organizational skills that challenged traditional assumptions about prehistoric social capabilities. The artistic traditions that emerged during this period incorporated both aesthetic and functional elements that served the dual purposes of cultural expression and information storage. Carved symbols weren't just decorative motifs, but encoded data about astronomical observations, mathematical relationships, and historical events that communities needed to preserve for future reference. The development of symbolic notation systems represented a crucial breakthrough in human communication technology. Communities needed methods for recording complex information that could be understood by future generations, even if oral traditions were disrupted. The symbols carved into megalithic monuments served as humanity's first libraries, storing essential knowledge in forms that could survive cultural and linguistic changes. These symbolic systems incorporated multiple layers of meaning that allowed single monuments to preserve different types of information simultaneously. Surface carvings might record historical events, while deeper structural elements encoded mathematical relationships and astronomical alignments. The monuments functioned as multi-dimensional databases that could be read at various levels depending on the reader's knowledge and needs. The religious and philosophical frameworks that developed around these monuments reflected new understandings of humanity's relationship to cosmic forces. Traditional animistic beliefs that located divine power in local natural phenomena expanded to incorporate celestial mechanics and universal principles that operated on scales far beyond immediate human experience. These theological developments weren't just abstract spiritual concepts, but practical frameworks for understanding and responding to environmental challenges. Religious narratives that emphasized cyclical time, cosmic order, and divine intervention provided conceptual tools for long-term planning and risk assessment that secular knowledge systems couldn't easily accommodate. Mythology became applied philosophy, helping communities maintain psychological resilience while working on projects that might require generations to complete. Ritual practices evolved to reinforce both cultural memory and technical knowledge through ceremonial activities that combined religious observance with practical education. Seasonal celebrations weren't just social gatherings, but training exercises that ensured essential skills and information passed from older to younger generations. Religious ceremony became educational technology disguised as spiritual practice. The social hierarchies that emerged to support these complex projects reflected both practical necessities and symbolic requirements for maintaining cultural continuity. Communities needed individuals capable of preserving specialized knowledge, coordinating large-scale construction efforts, and maintaining communication with distant groups. The emergence of priestly classes, master builders, and astronomical observers represented functional specialization rather than arbitrary social stratification. These specialized roles required educational systems that could transmit complex technical knowledge across generations while maintaining accuracy and precision. Traditional apprenticeship models proved inadequate for preserving the mathematical and astronomical concepts necessary for monument construction and maintenance. Formal educational institutions began developing to ensure that essential capabilities survived, even if their current practitioners didn't. The curricula of these early educational systems focused heavily on practical skills required for cosmic threat detection and community survival. Students learned astronomical observation techniques, mathematical calculation methods, and engineering principles alongside traditional crafts and agricultural knowledge. Education became preparation for participation in humanity's ongoing effort to understand and predict cosmic behavior. The psychological dimensions of this educational process were as important as the technical content. Communities needed to maintain motivation for long-term projects while processing trauma from past catastrophes and anxiety about future threats. Educational systems incorporated both intellectual training and emotional support that helped individuals develop the psychological resilience necessary for multi-generational thinking. The development of writing systems during this period reflected both practical needs for information storage and symbolic requirements for cultural identity preservation. Early scripts weren't just communication tools, but methods for creating permanent records that could preserve essential knowledge across periods of social disruption or cultural change. The mathematical concepts embedded in early writing systems revealed sophisticated understanding of numerical relationships and geometric principles that connected symbolic representation to cosmic order. Letters and numbers weren't arbitrary symbols, but components of larger systems that encoded both practical information and philosophical concepts about universal principles. The standardization of writing systems across different communities created common languages for sharing technical knowledge and coordinating complex projects. Groups separated by thousands of miles could communicate precise mathematical calculations, architectural specifications, and astronomical observations using standardized notation systems that transcended local linguistic differences. The administrative applications of writing technology supported increasingly complex social and economic organization that required record-keeping capabilities beyond the limits of human memory. Communities were managing agricultural production schedules, craft manufacturing programs, and trade relationships that generated information flows too complex for oral tradition alone to maintain. The literary applications of writing preserved cultural narratives and historical accounts that maintained community identity while documenting lessons learned from past experiences. Epic poems, creation myths, and historical chronicles weren't just entertainment, but educational materials that transmitted essential cultural knowledge through engaging narrative formats. The legal applications of writing created formal systems for establishing rights, obligations, and dispute resolution procedures that could maintain social order within increasingly complex communities. Written law codes represented attempts to codify decision-making processes that balanced individual interests against collective needs while maintaining consistency across different cases and circumstances. The scientific applications of writing enabled systematic documentation of observations, experiments, and theoretical developments that accelerated the pace of knowledge advancement. Communities could build upon previous discoveries rather than repeatedly rediscovering the same principles, creating cumulative research programs that produced increasingly sophisticated understanding of natural processes. The economic applications of writing supported trade relationships and resource management systems that required precise record-keeping and contractual agreements. Written contracts, inventory records, and accounting systems enabled communities to participate in complex exchange networks while maintaining accurate documentation of transactions and obligations. The diplomatic applications of writing facilitated communication between different communities and cultural groups that needed formal protocols for negotiation, agreement, and conflict resolution. Written treaties and diplomatic correspondence created permanent records of international relationships that could survive changes in leadership and political circumstances. The artistic integration of writing with visual design created aesthetic products that combined beauty with functionality in ways that ensured cultural preservation through intrinsic appeal. Illuminated manuscripts, decorated inscriptions, and symbolic artwork weren't just practical documents, but cultural treasures that communities valued enough to preserve through difficult periods. The technological innovations that accompanied writing development included improvements in materials processing, tool manufacture, and surface preparation that enhanced the durability and legibility of written records. Communities invested significant resources in developing inks, papers, and carving techniques that could create documents capable of surviving for centuries or millennia. The geographical expansion of writing systems created information networks that connected communities across vast distances while preserving local cultural distinctiveness. Standardized scripts could transmit technical information across linguistic boundaries, while allowing each community to maintain its unique oral traditions and cultural practices. The temporal dimensions of writing created connections between past and future that enabled communities to learn from historical experience while planning for long-term projects. Written records preserved lessons learned from previous generations, while documenting contemporary developments for future reference. Communities could engage in conscious cultural evolution guided by accumulated wisdom rather than just immediate experience. The metallurgical advances that occurred during this period reflected both practical needs for improved tools and symbolic requirements for creating permanent cultural artifacts. Metalworking technologies developed rapidly as communities sought materials that could withstand the physical and environmental stresses of monument construction, while serving ceremonial functions that reinforced cultural identity. The chemistry of metal production required sophisticated understanding of temperature control, chemical reactions, and material properties that implied systematic experimentation and theoretical development. Communities were conducting applied research programs that produced increasingly refined techniques for extracting, purifying, and shaping metals according to specific performance requirements. The economics of metallurgy created trade relationships that connected resource-rich regions with manufacturing centers, while distributing finished goods products across expanding commercial networks. Metal goods became both practical tools and valuable commodities that supported economic development, while facilitating cultural exchange between distant communities. The social organization of metal production created new occupational specializations that required technical training and sustained resource investment. Master smiths, miners, and metalworkers became distinct social categories with specific skills and responsibilities that contributed to community capabilities while creating internal economic differentiation. The artistic applications of metallurgy produced decorative objects and ceremonial artifacts that combined aesthetic appeal with symbolic meaning in ways that reinforced cultural values while demonstrating technical capabilities. Metal artwork became both cultural expression and technological advertisement that enhanced community prestige while preserving artistic traditions. The military applications of metallurgy created improved weapons and defensive equipment that enhanced community security while supporting the social hierarchies necessary for organizing large-scale construction projects. Metal weapons weren't just combat tools, but symbols of authority that reinforced leadership roles, while providing practical capabilities for community protection. The agricultural applications of metallurgy produced farming implements that increased agricultural productivity while reducing labor requirements for food production. Metal tools enabled communities to invest more resources in monument construction and knowledge preservation, while maintaining adequate food supplies for growing populations. The architectural applications of metallurgy provided structural elements and fastening systems that enhanced building durability, while enabling more ambitious construction projects. Metal reinforcements allowed communities to build larger and more complex structures that could serve multiple functions while withstanding environmental stresses over extended periods. The scientific applications of metallurgy created precision instruments for astronomical observation and mathematical calculation that enhanced research capabilities, while enabling more accurate monument alignments. Metal tools became scientific equipment that supported the technical requirements of cosmic threat detection and prediction systems. The transportation applications of metallurgy improved travel capabilities and cargo handling systems that supported the communication networks necessary for coordinating international monument construction projects. Metal vehicle components and navigation instruments enabled communities to maintain contact across vast distances while transporting materials and personnel required for complex construction efforts. The hydraulic engineering projects that emerged during this period demonstrated sophisticated understanding of water management principles that required both theoretical knowledge and practical experience with large-scale construction techniques. Communities were designing and building irrigation systems, flood control structures, and water storage facilities that modified entire watersheds according to human requirements. The mathematical foundations of hydraulic engineering included advanced geometry and physics concepts that connected local water management decisions to regional environmental processes. Communities needed to calculate water flow rates, pressure differentials, and structural load requirements that demanded mathematical tools beyond basic arithmetic and measurement techniques. The environmental impact of hydraulic projects created anthropogenic landscapes that represented humanity's first systematic attempts to redesign natural systems according to conscious planning rather than gradual adaptation. These modifications weren't just practical interventions, but expressions of recovered confidence in human agency after experiencing cosmic powerlessness. The social coordination required for hydraulic construction created new forms of collective decision-making and resource allocation that balance individual property rights against community water management needs. Legal frameworks developed to regulate water access and usage while maintaining incentives for individual investment in land improvement and infrastructure development. The economic benefits of hydraulic engineering supported population growth and agricultural intensification that provided the resource base necessary for monument construction and knowledge preservation activities. Improved water management created agricultural surpluses that could support specialized occupations while enhancing community resilience against environmental variations. The technological innovations associated with hydraulic engineering included developments in surveying, construction, and materials processing that enhanced general engineering capabilities while supporting other infrastructure projects. Hydraulic engineering became a training ground for technical skills that could be applied to monument construction, urban planning, and industrial development. The international dimensions of hydraulic engineering created shared watersheds that required cooperation between different communities while providing opportunities for technology transfer and cultural exchange. Water management systems became diplomatic tools that encouraged peaceful relationships while creating economic interdependencies that supported regional stability. The long-term planning requirements of hydraulic projects encouraged communities to think in terms of generational timescales while developing institutional structures, capable of maintaining complex systems across multiple leadership transitions. Water management became a template for other long-term projects that required sustained commitment and organizational continuity. The symbolic significance of hydraulic engineering connected practical water management to religious and philosophical concepts about cosmic order and human responsibility for environmental stewardship. Water control systems became metaphors for social organization and divine authority that reinforced cultural values while serving practical functions. The educational applications of hydraulic engineering created opportunities for technical training and knowledge transmission that enhanced community capabilities while preserving engineering knowledge across generations. Hydraulic projects became practical laboratories where communities could develop and refine construction techniques while training new generations of engineers and planners. The survivors who emerged from the cosmic catastrophe carried more than just technical knowledge and construction skills. They bore psychological adaptations that would fundamentally reshape human consciousness itself. The trauma of witnessing their world consumed by fire and flood had created mental frameworks entirely different from anything their ancestors had possessed. Fear became a teacher more powerful than any elder, and uncertainty became the foundation for humanity's first systematic approaches to controlling an unpredictable future. Archaeological evidence from settlement sites across the post-impact landscape revealed behavioral patterns that spoke to deep psychological transformation. Communities began constructing not just shelters, but fortified compounds with multiple escape routes and underground storage chambers. These weren't defensive positions against human enemies, but architectural responses to cosmic anxiety, built by people who had learned that safety was always temporary and catastrophe could arrive without warning from any direction. The storage obsession that characterized these communities went far beyond practical resource management. Excavations revealed caches of tools, seeds, preserved foods, and raw materials buried in multiple locations around each settlement, often in quantities that exceeded any reasonable seasonal preparation. These were insurance policies against extinction, redundant systems designed by minds that had witnessed how quickly abundance could transform into scarcity. Social structures evolved to accommodate this new relationship with uncertainty. Traditional leadership based on immediate decision-making gave way to councils focused on long-term planning and risk assessment. Communities needed individuals capable of maintaining focus on projects that might require centuries to complete, while simultaneously preparing for disasters that might arrive at any moment. The emergence of specialized roles for threat assessment and disaster preparation represented humanity's first attempts at systematic risk management. The development of early warning networks reflected this same psychological adaptation to cosmic vulnerability. Communities established signal systems using fires, drums, and carved markers that could communicate across vast distances about unusual celestial events, environmental changes, or other potential threats. These networks weren't just practical communication tools, but psychological comfort mechanisms that helped scattered groups feel connected to larger survival systems. The mathematical concepts that emerged during this period reflected cognitive adaptations to processing information about cyclical time and probability assessment. Traditional thinking that focused on immediate cause and effect proved inadequate for understanding cosmic events that operated on timescales far beyond individual experience. Communities developed conceptual frameworks for thinking in terms of centuries and millennia while maintaining attention to immediate survival needs. The astronomical observations that dominated intellectual life during this era weren't pursued from abstract curiosity, but from desperate practical necessity. Every unusual star pattern, every unexpected celestial movement, every deviation from predicted cycles represented potential warning signs that required immediate attention and careful analysis. Astronomy became applied paranoia, the systematic study of cosmic behavior motivated by existential fear rather than philosophical wonder. The precision demanded by these observations pushed human intellectual capabilities in directions that peaceful agricultural societies might never have explored. Communities needed to detect subtle variations in stellar positions, track complex orbital relationships, and predict future celestial events with accuracy that left no margin for error. The stakes were too high for approximate calculations or casual observations. The educational systems that developed to transmit this knowledge incorporated both intellectual training and psychological conditioning designed to maintain vigilance across generations. Children learn not just technical skills, but mental habits of constant observation, systematic record-keeping, and worst-case scenario planning. Education became preparation for perpetual emergency, creating minds capable of functioning effectively under conditions of permanent uncertainty. The religious frameworks that emerged during this period reflected humanity's new relationship with cosmic forces that had revealed themselves as both creative and destructive. Traditional animistic beliefs that located divine power in predictable natural phenomena expanded to incorporate concepts of cosmic chaos and divine unpredictability that required constant vigilance and ritual preparation. Deities associated with sky, fire, and transformation gained prominence over earth-based spirits that seemed inadequate to explain planetary, abstract spiritual concepts but practical psychological scale catastrophes. These theological developments weren't just tools for managing anxiety about future cosmic events. Religious narratives that emphasized cyclical destruction and renewal provided frameworks for understanding catastrophe as part of natural order rather than random disaster. Mythology became applied psychology, helping communities maintain emotional stability while working on projects that acknowledged the possibility of future extinction. Ritual practices evolved to serve multiple functions simultaneously, combining religious observance with practical training, emotional processing, and social bonding activities that reinforced community resilience. Ceremonial reenactments of cosmic events provided opportunities for trauma processing while preserving historical memory and maintaining technical knowledge about disaster response procedures. The architectural innovations that appeared during this period incorporated both functional and symbolic elements designed to address psychological as well as practical needs. Buildings weren't just constructed for shelter, but designed as integrated systems for community coordination, resource management, and emotional support during crisis situations. Architecture became applied psychology, creating environments that could maintain social cohesion under extreme stress. The artistic traditions that flourished in post-impact communities served similar psychological functions, providing methods for processing traumatic experiences while preserving cultural memory and maintaining community identity. Artistic expression became a form of emotional technology that helped individuals and groups cope with ongoing anxiety, while creating cultural products that reinforced social bonds and shared values. The musical developments of this era incorporated rhythmic and melodic patterns that serve both aesthetic and functional purposes, creating sound environments that could facilitate group coordination while providing emotional regulation and stress relief. Music became a tool for community management that could maintain social harmony while supporting the psychological resilience necessary for long-term projects. The dance traditions that emerged combined physical exercise with social bonding and cultural expression in ways that addressed the community's needs for both individual health and collective identity. Group dances became therapeutic activities that provided stress relief while reinforcing social connections and cultural continuity across generational transitions. The storytelling practices that developed during this period incorporated both entertainment and educational functions that preserved essential knowledge while providing psychological comfort and social bonding opportunities. Narrative traditions became information storage systems disguised as entertainment that could maintain cultural memory while supporting emotional processing of traumatic experiences. The craft specializations that emerged reflected both practical needs for improved technologies and psychological requirements for meaningful work that could provide individuals with sense of purpose and community value. Specialized occupations became identity frameworks that help people maintain psychological stability while contributing to collective survival efforts. The trade relationships that developed between communities served economic functions while providing psychological benefits of connection and mutual support that reduced feelings of isolation and vulnerability. Commercial networks became social support systems that helped scattered groups maintain confidence in their collective survival capabilities. The legal systems that emerged to manage increasingly complex social relationships incorporated both practical dispute resolution mechanisms and psychological frameworks for maintaining social order under conditions of ongoing stress. Legal codes became tools for community mental health that could prevent social breakdown while maintaining individual rights and collective responsibilities. The technological innovations that characterized this period reflected both practical problem-solving capabilities and psychological needs for agency and control in an environment that had demonstrated human vulnerability to cosmic forces. Technical development became a form of applied optimism that helped communities maintain confidence in their ability to influence their circumstances. The agricultural intensification that occurred during these centuries represented more than just improved food production techniques. It embodied psychological adaptation to uncertainty that emphasized preparation, redundancy, and self-sufficiency over traditional approaches that assumed environmental stability. Farming became applied anxiety management that addressed both practical nutritional needs and emotional requirements for security and control. The water management systems that communities constructed reflected understanding that environmental control required systematic intervention rather than simple adaptation. Hydraulic engineering became a metaphor for human agency that demonstrated community capability to reshape natural systems according to conscious planning rather than random circumstance. The metallurgical developments that accelerated during this period provided both improved tools and psychological symbols of human technical capability that countered feelings of helplessness induced by cosmic catastrophe. Metalworking became applied confidence building that created tangible evidence of human ability to transform raw materials according to conscious design. The transportation innovations that facilitated communication between distant communities addressed both practical needs for coordination and psychological requirements for connection and mutual support. Improved travel capabilities became tools for community mental health that reduced isolation while enabling resource sharing and knowledge exchange. The writing systems that developed during this era serve both practical information storage functions and psychological purposes related to cultural identity preservation and intergenerational communication. Written language became a form of applied immortality that could preserve human knowledge and experience beyond individual lifespans and local disasters. The mathematical concepts that emerged reflected cognitive adaptations to processing complex information about probability, risk assessment, and long-term planning under conditions of uncertainty. Mathematical thinking became a psychological tool for managing anxiety about unpredictable futures, while enabling rational decision-making about resource allocation and project planning. The engineering capabilities that communities developed incorporated both technical problem-solving skills and psychological frameworks for approaching complex challenges that required sustained effort and coordination. Engineering became applied optimism that demonstrated human ability to solve problems through systematic analysis and coordinated action. The urban planning concepts that guided settlement development reflected understanding that community organization required conscious design rather than random growth. Town planning became applied social psychology that created environments capable of supporting both individual well-being and collective functionality under various stress conditions. The international diplomatic protocols that emerged to manage relationships between different communities incorporated both practical conflict resolution mechanisms and psychological frameworks for maintaining peaceful cooperation despite competition for resources and territory. Diplomacy became applied trust building that enabled communities to work together despite underlying anxiety about future scarcity and conflict. The economic systems that developed reflected understanding that resource allocation required institutional frameworks capable of balancing individual needs against collective requirements while maintaining incentives for productive activity. Economic organization became applied social engineering that could maintain community functionality while supporting individual motivation and creativity. The educational institutions that emerged incorporated both knowledge transmission functions and psychological development programs designed to prepare individuals for participation in complex social systems, while maintaining emotional resilience under conditions of ongoing uncertainty. Education became applied character development that created citizens capable of contributing to collective survival efforts while maintaining individual identity and agency. The scientific methodologies that communities developed reflected systematic approaches to understanding natural processes that combined practical observation with theoretical analysis in ways that enabled prediction and control of environmental conditions. Scientific thinking became applied pattern recognition that could identify potential threats while developing effective response strategies. The philosophical frameworks that emerged during this period incorporated both practical wisdom about human behavior and theoretical understanding of cosmic relationships that provided conceptual tools for making sense of complex experiences while maintaining psychological stability. Philosophy became applied meaning-making that helped individuals and communities find purpose and direction despite ongoing uncertainty about future circumstances. The cultural preservation activities that characterized this era reflected understanding that community identity required conscious maintenance through institutional mechanisms capable of transmitting essential values and practices across generational transitions. Cultural work became applied immortality that could preserve human achievements beyond individual lifespans and local disasters. The artistic integration that occurred during this period combined aesthetic expression with practical functionality in ways that created cultural products capable of serving multiple purposes simultaneously. Art became applied beauty that could provide psychological comfort while preserving essential information and reinforcing community values through intrinsically appealing forms. The recreational activities that developed reflected understanding that community mental health required opportunities for relaxation, social bonding, and individual expression that could provide stress relief while maintaining social connections. Recreation became applied therapy that supported psychological resilience while creating opportunities for cultural expression and social coordination. The ceremonial practices that evolved during this era incorporated both religious observance and practical community functions that addressed psychological needs for meaning and connection while serving social coordination and cultural preservation purposes. Ceremony became applied spirituality that could maintain community cohesion while providing frameworks for processing complex experiences and emotions. The seasonal celebrations that emerged reflected understanding that community psychological health required regular opportunities for collective joy and cultural expression that could counteract ongoing anxiety about future threats while reinforcing social bonds and shared identity. Festivals became applied happiness that supported mental health while creating opportunities for cultural transmission and social bonding. The healing practices that developed during this period incorporated both medical treatment and psychological support that addressed physical health needs while providing emotional comfort and social support during illness and injury. Medicine became applied compassion that supported individual recovery while maintaining community health and resilience. The conflict resolution mechanisms that communities created reflected understanding that social harmony required institutional frameworks capable of managing disputes while maintaining relationships and preventing escalation to violence. Peacemaking became applied wisdom that could resolve differences while preserving community unity and cooperative capabilities. The resource management systems that emerged incorporated both practical allocation mechanisms and psychological frameworks for maintaining community cooperation, despite competition for limited materials and opportunities. Resource sharing became applied trust that could ensure equitable distribution while maintaining incentives for individual productivity and contribution. The disaster preparedness protocols that communities developed reflected systematic approaches to risk management that combined practical emergency response capabilities with psychological preparation for crisis situations. Emergency planning became applied resilience that could maintain community functionality while supporting individual and collective capacity to cope with unexpected challenges and disruptions. The knowledge preservation activities that characterized this era reflected understanding that community survival required institutional mechanisms capable of maintaining essential information across generational transitions and environmental disruptions. Information management became applied foresight that could ensure continuity of crucial capabilities while supporting ongoing learning and adaptation to changing circumstances. The technological development programs that communities pursued incorporated both practical innovation activities and psychological frameworks for maintaining confidence in human capability to solve problems and improve conditions through systematic effort and creativity. Technical progress became applied hope that demonstrated human agency while creating tangible improvements in community capabilities and individual well-being. The communication networks that emerged during this period reflected understanding that community survival required coordination capabilities that could maintain information flow and mutual support across vast distances and diverse environmental conditions. Communication became applied connection that could preserve social bonds while enabling practical cooperation and resource sharing between distant groups. The transportation systems that developed incorporated both practical mobility capabilities and psychological frameworks for maintaining community connections despite geographic separation and environmental challenges. Travel became applied courage that could overcome isolation while supporting trade, communication, and cultural exchange between distant communities. The architectural preservation activities that communities pursued reflected understanding that physical structures required conscious maintenance to serve their intended functions across extended time periods and changing environmental conditions. Building maintenance became applied continuity that could preserve community investments while supporting ongoing functionality and cultural identity. The environmental management practices that emerged incorporated both practical resource conservation techniques and psychological frameworks for maintaining sustainable relationships with natural systems, despite pressure for immediate resource exploitation. Environmental stewardship became applied responsibility that could balance present needs against future requirements while maintaining ecosystem health and productivity. The population management strategies that communities developed reflected understanding that demographic balance required conscious attention to birth rates, death rates, and migration patterns that could maintain community viability while avoiding resource depletion or social instability. Population planning became applied prudence that could ensure sustainable community growth while maintaining individual reproductive rights and family autonomy. The social integration practices that emerged during this period incorporated both practical mechanisms for incorporating new members and psychological frameworks for maintaining community cohesion despite cultural diversity and individual differences. Social inclusion became applied acceptance that could preserve community unity while supporting individual identity and cultural expression. The leadership development programs that communities created reflected understanding that effective governance required systematic preparation of individuals for complex decision-making responsibilities that balanced competing interests while maintaining community functionality. Leadership training became applied wisdom that could prepare capable administrators while maintaining democratic participation and individual rights. The innovation encouragement activities that characterized this era reflected understanding that community adaptation required institutional support for creativity and experimentation that could develop new solutions while maintaining social stability and cultural continuity. Innovation support became applied creativity that could foster beneficial change while preserving essential community values and practices. These psychological adaptations represented more than just individual coping mechanisms. They constituted a fundamental transformation in human consciousness that would influence every subsequent development in human civilization. The cosmic catastrophe had forced rapid evolution not just of human technologies and social structures, but of human mental capabilities themselves. The survivors who witnessed the sky fall and the world transform had become something new. They were humanity's first systematic planners, risk managers, and long-term thinkers. Their minds had been shaped by forces that demanded capabilities no previous generation had needed to develop. They thought in terms of centuries while acting in moments, planned for disasters while building for permanence, and created beauty while preparing for destruction. Their legacy lived on not just in the monuments they constructed or the technologies they developed, but in the very structure of human consciousness itself. Every subsequent civilization would inherit their mental frameworks for dealing with uncertainty, their approaches to long-term planning, and their understanding that survival required both practical preparation and psychological resilience. The cosmic impact that had nearly destroyed human civilization ultimately became the catalyst for humanity's transformation into something far more sophisticated and adaptable than anything that had existed before. The survivors had responded to catastrophe not with despair, but with determination, creating systems of knowledge, cooperation, and cultural preservation that would outlast any individual community or generation. Their story was written not just in stone and metal, but in the fundamental patterns of human thought and behavior that would characterize our species for thousands of years to come. The day the sky fell had ended one chapter of human history, but begun another that was still being written by every generation that inherited their legacy of resilience, innovation, and hope. The transformation wasn't merely technological or social, something deeper had shifted in the human psyche itself. The survivors who emerged from the cosmic fire carried within their minds a new architecture of thought, one forged by necessity and tempered by loss. They had witnessed the impossible become inevitable, and that witnessing had rewired the very foundations of human consciousness. In the settlements that rose from the ashes, archaeologists have found evidence of behavioral patterns that speak to this psychological revolution. Communities began constructing not just homes, but sanctuaries, structures designed with multiple chambers and hidden passages that serve no obvious practical purpose. These weren't defensive fortifications against human enemies, but psychological refuges, spaces where minds traumatized by cosmic violence could find comfort in controlled environments. The art that emerged from these communities revealed the depth of their transformation. Cave paintings and carved reliefs depicted not just the familiar animals and hunting scenes of earlier cultures, but abstract patterns that seemed to map invisible forces. Spirals within spirals, radiating lines that suggested explosion or implosion, geometric forms that captured the mathematics of catastrophe itself. These weren't decorative choices, but therapeutic necessities, attempts to process experiences that exceeded the capacity of normal human understanding. The languages that developed during this period incorporated new conceptual frameworks for describing time, causation, and probability that reflected fundamentally altered ways of thinking about existence. Words emerged for concepts that had never needed expression before. Terms for different types of endings, gradations of uncertainty, and varieties of preparation that distinguished between normal seasonal planning and preparations for world-ending events. These linguistic innovations spread rapidly between communities, suggesting that the psychological transformation was universal rather than localized. Survivors across continents were developing similar mental frameworks for processing cosmic trauma, creating parallel vocabularies for experiences that transcended cultural boundaries. The impact had affected not just individual minds, but the collective human psyche itself. The educational systems that emerged reflected this new understanding of mental development. Children weren't just taught skills and knowledge, but cognitive habits of systematic observation, pattern recognition, and long-term consequence evaluation. Education became mental conditioning for living in a universe that had revealed its capacity for sudden violence, creating minds capable of functioning effectively under conditions of permanent uncertainty. The rituals that developed around astronomical observation took on dimensions that went far beyond simple calendar keeping or navigation. These became exercises in collective psychology, community activities that maintained group vigilance while processing ongoing anxiety about future cosmic events. Star watching became a form of applied therapy that channeled individual fears into productive group activities. The agricultural practices that emerged during this period reflected similar psychological adaptations. Communities didn't just grow food, but created elaborate systems of crop rotation, seed storage, and land management that assumed recurring cycles of destruction and recovery. Farming became an expression of qualified optimism, a bet on the future that acknowledged the possibility of catastrophic interruption while maintaining commitment to long-term productivity. The technological innovations incorporated both practical functionality that characterized this era and psychological comfort in ways that addressed emotional as well as material needs. Tools weren't just designed for efficiency, but for durability that could survive disruption, beauty that could provide aesthetic comfort during difficult periods, and symbolic meaning that reinforced cultural values and community identity. The social hierarchies that developed reflected understanding that community survival required individuals capable of maintaining focus on generational projects while managing immediate crises. Leadership roles became associated with psychological as well as technical capabilities, selecting for individuals who could make decisions under extreme uncertainty while maintaining community morale and cooperative spirit. The trade networks that emerged served psychological functions alongside economic ones, creating connections between distant communities that provided mutual reassurance about collective human survival. Commercial relationships became emotional support systems that countered feelings of isolation while distributing both material resources and psychological comfort across expanding geographic regions. The legal systems that developed incorporated mechanisms for managing conflict and uncertainty that addressed the psychological dimensions of social organization. Laws weren't just practical rules, but frameworks for maintaining community mental health under conditions of ongoing stress, creating predictable social environments that could provide psychological stability despite environmental uncertainty. The architectural innovations of this period created built environments that serve both practical and psychological functions, designing spaces that could support community activities while providing emotional comfort and symbolic meaning. Buildings became tools for collective psychology that could maintain social cohesion while accommodating the complex needs of traumatized populations recovering from cosmic catastrophe. The artistic traditions that flourished incorporated aesthetic elements that served therapeutic functions, creating visual and auditory experiences that could provide emotional regulation while preserving cultural memory. Art became applied psychology disguised as cultural expression, helping individuals and communities process complex emotions while maintaining creative vitality and cultural identity. The musical developments that occurred reflected understanding that sound could serve both practical communication functions and emotional regulation purposes. Musical traditions became technologies for community mental health that could coordinate group activities while providing stress relief and emotional expression opportunities for individuals dealing with ongoing trauma and uncertainty. The storytelling practices that emerged combined entertainment with emotional processing in ways that helped communities make sense of their experiences while preserving cultural knowledge. Narrative traditions became therapeutic tools that could provide psychological comfort while transmitting essential information about survival strategies and community values across generational transitions. The ceremonial activities that developed served multiple psychological functions simultaneously, providing opportunities for collective emotional expression while reinforcing social bonds and cultural identity. Rituals became applied community psychology that could maintain group cohesion while addressing individual needs for meaning and connection in a universe that had demonstrated its indifference to human welfare. The healing practices that emerged incorporated understanding of the connections between physical and psychological health, developing treatment approaches that addressed both bodily ailments and emotional trauma. Medicine became holistic therapy that recognized the integrated nature of human well-being, while providing practical treatment for both injury and psychological distress. The recreational activities that developed reflected recognition that community mental health required opportunities for joy and relaxation that could counterbalance ongoing anxiety about future threats. Recreation became applied happiness that supported psychological resilience while creating opportunities for social bonding and cultural expression that reinforced community identity and values. The seasonal celebrations that evolved incorporated both practical community coordination functions and psychological support activities that helped maintain collective morale throughout annual cycles. Festivals became tools for community mental health that could provide regular opportunities for joy while reinforcing social connections and cultural traditions that supported individual and collective resilience. The communication systems that developed addressed both practical coordination needs and psychological requirements for connection and mutual support. Information networks became emotional support systems that could maintain community bonds, while facilitating resource sharing and collaborative problem-solving activities across vast distances and diverse environmental conditions. The transportation innovations that occurred reflected understanding that mobility serves psychological as well as practical functions, enabling communities to maintain connections that provided emotional support while facilitating trade and cultural exchange. Travel technologies became tools for mental health that could counter isolation while supporting economic and social relationships that enhanced community resilience. The resource management systems that emerged incorporated psychological dimensions of scarcity and abundance that recognized the emotional impact of material conditions on individual and community well-being. Economic organization became applied psychology that could maintain social cooperation while addressing both practical needs and emotional requirements for security and fairness. The environmental management practices that developed reflected understanding that human relationships with natural systems had psychological as well as practical dimensions. Environmental stewardship became applied therapy that could provide sense of agency and purpose while maintaining sustainable resource use patterns that supported both ecological health and community psychological well-being. The population management strategies that communities adopted incorporated recognition that demographic patterns affected community psychology as well as resource availability. Population planning became applied social psychology that could maintain optimal community size while supporting individual reproductive choices and family formation patterns that enhance both social stability and personal satisfaction. The technological development programs that emerged reflected understanding that innovation served psychological functions alongside practical ones, providing communities with sense of agency and progress that countered feelings of helplessness induced by cosmic catastrophe. Technical advancement became applied optimism that could maintain community confidence while creating tangible improvements in living conditions and survival capabilities. The knowledge preservation activities that characterized this era incorporated psychological dimensions of cultural continuity that recognized the emotional importance of maintaining connections between past and future generations. Information management became applied immortality that could provide sense of permanence while ensuring that essential knowledge survived individual deaths and community disruptions. The disaster preparedness protocols that developed addressed both practical emergency response needs and psychological requirements for feeling prepared and capable of handling future crises. Emergency planning became applied confidence building that could reduce anxiety while creating realistic capabilities for managing various types of disruption and catastrophe. The evidence stretches across continents and millennia, written in stone and sediment, encoded in genes, and carved into monuments that still pierce the sky. From the shocked quartz of Abu Huraira to the astronomical precision of Göbekli Tepe, from the channeled scablands of Washington to the genetic signatures preserved in our own DNA, the story emerges with startling clarity. 12,800 years ago, something fell from the heavens and changed everything. The cosmic impact that ended the last ice age didn't just alter Earth's climate or trigger mass extinctions. It forged a new kind of human consciousness, one capable of thinking in centuries while acting in moments, of building for eternity while preparing for catastrophe. The survivors who witnessed their world consumed by fire and flood became humanity's first systematic planners, our first scientists, our first architects of permanence in an impermanent cosmos. Their monuments weren't tombs or temples, but time capsules, repositories of knowledge encoded in stone by minds that understood how quickly everything could vanish. Their agricultural revolution wasn't gradual adaptation, but desperate innovation, the work of people who had seen their food sources disappear overnight. Their trade networks weren't commercial conveniences, but lifelines connecting scattered survivors who recognized that individual communities could not face the cosmos alone. The transformation they underwent reverberates still. Every city we build, every technology we develop, every system we create to preserve knowledge across generations carries their imprint. We are their descendants, not just genetically, but psychologically, inheritors of mental frameworks forged in cosmic fire. Our capacity for long-term planning, our drive to understand celestial mechanics, our compulsion to build monuments that outlast their builders, all trace back to those desperate centuries when humanity learned to think beyond the immediate and prepare for the unthinkable. The debate over the Younger Dryas impact hypothesis continues in academic journals and research laboratories, but the monuments themselves need no peer review. They stand as silent witnesses to transformation, proof that catastrophe can catalyze rather than merely destroy. The sky fell once before, and from its ashes rose civilization itself. In our own age of climate change and cosmic awareness, their legacy takes on new urgency. We have inherited both their capabilities and their vulnerabilities, their knowledge and their fears. The question is not whether such events can happen again, but whether we have preserved enough of their hard-won wisdom to recognize the signs and respond with their same determined hope. The stars still wheel overhead as they did then, following patterns our ancestors mapped with desperate precision. And somewhere in that vast darkness, other fragments drift, waiting for gravity to call them home.